Hi, I just wanted to demonstrate my portable charging system for this electric vehicle, the SparkEV. So I've actually got three marine cycle batteries here. Three marine deep cycle batteries, 120 RC on each battery. I have two bus bars here. I've got the bus bar connecting all the negative terminals together, and then I have the bus bar here, which I've put some insulation tape over it for safety, because you don't want to accidentally short these two bus bars together with a wrench or something like that. That's going to cause a big spark and possibly explode the batteries and do some really major damage. So you do want to insulate that bus bar. So that's connecting all the positive terminals together. And then I have this inverter here, which is a 1200 watt continuous 2400 watt surge pure sine wave inverter. And so what this does is takes the 12 volt DC from the batteries and converts that into an AC 120 volt sine wave, which is basically the same as your household power. So I've got the negative bus bar here going into the negative of the inverter, and then the red is the positive going up here to the positive bus bar of the inverter. One thing to note is I have this 175 amp fuse here in series with the inverter and batteries. That's just in case something goes majorly wrong with the inverter and it starts to short out and try to draw too much current through these batteries. I don't want the batteries exploding or any other hazards, so I have that fuse in there just for safety. The inverter itself does have fuses built in too, but this is just to be extra safe. And then I have actually have this ground connection here that goes to the case of the inverter, and I haven't hooked this up yet. I'll need to do that too, but basically you just need to hook that up to the chassis of the vehicle so that the case of this thing is grounded in the event that this thing malfunctions and you get a positive the positive terminal of the battery connected to this. You don't want this thing to be charged up where you could potentially get electrocuted. So that's therefore just making sure this case is grounded for safety reasons. So again, 12 volts coming in and 120 volts coming out, and I have it going here through the seat. So let me go over to the other side. And on the other side here, you'll see I just have a standard power strip, on-off strip. So I'll just set that in the off position. And then over here is the charger for the car. Normally you would plug this into the wall, 120 volt socket, but again, this is a portable range extender so that I can charge the car after I've driven it for some time and I don't have access to electric outlet. So I've got this here, and then I've got this going over to the driver's seat is actually looping through the window over here. And there's the charge port. So let me go ahead and demonstrate how this works. Come back over here. So I'll go ahead and turn the inverter on. There's a button if I can find it somewhere over here. Yep. So you hear that, it's on now. I fit 3 batteries in here. I could have fit 4, possibly 5, maybe if I would have moved the inverter to that back seat over there where the charger is. I'm pretty sure I could have fit 5 batteries in here. But these things are kind of expensive, $100 a piece. So this was just the first go at it to see what would happen. So I've turned the inverter on. I'll come over here and I'll turn the power strip on, and that'll get this guy ready to charge. Now I'll actually need to plug it in. So let's see if I can, there we go. So that's plugged in, and you'll come over here to the charge LED of the car. You hear how it honks like that? That means it's charging, and that LED is a solid green, which means it's charging. So if I come over here to the the driver's side, you can see that it actually says charging and gives the battery range, and you can see it's charging 120 volts. One thing to be careful on these Sparks is just to make sure you have the correct charge setting. There's an 8 amp setting and a 12 amp setting. So let me go ahead and crawl in here so I can demonstrate that. Turn the car on. So let's see. I went over to the here to the charge setting. You'll see that it says current charge level is 8 amps. You can change this to 12, but again, my system's only sized for an 8 amp setting, and then I have the charge level is immediate because I don't want to set this to time of day, otherwise it won't charge. If I'm charging at home, I'll set that to time of day so it can charge at night for cheaper, but for this portable charger, it doesn't matter when I charge it. I'm charging off batteries, so I want to have that say immediately, so that it's charging immediately. So I'll go ahead and turn the car off, and let's see, just make sure it's still charging here. Yeah, still charging. Okay. So again, it's charging, and coming back over here, see the green LED there, that means it's charging, there's no faults. And there we go. So that's the first video. I just wanted to demonstrate how this actually works. One other thing to note is I have these switches here that are rated at 100 amp. So I wanted to actually install that in series here with one of these terminals. So I could take this negative off and install the switch here so that I could switch on and off. I could open the circuit and determine whether I want that inverter connected or not. So that's going to be useful because when I want to go and charge this guy, I don't want the inverter to be powered on while I'm charging the batteries. So if I come on over here to the other side of the car, you can see I actually have this charger here. I don't have it hooked up right now, but I'll show you later that I've got this charger here, and I've got a little kilowatt meter here because I was experimenting, seeing how much power it was drawing and whatnot. So I'll talk about that in another video, but the point is that I was going to hook this up, probably again go through the seat like that, through the middle of the seat, and have this charger here, and then I have it so I can plug it in, use an extension cord and plug it in. So I'd actually be hauling this charger around with the car too, along with the batteries and the inverter. You could leave this outside in your garage or something, but then you're gonna have to figure out how to disconnect and connect the 12 volts to the batteries every time, so that's gonna be kind of a pain. I didn't really think of a good way of doing that. There's not really any connectors that, I'm sure there are connectors that are rated 100 amp or something really high like that, but I wasn't able to find anything really quickly, so I'll just leave this. It's only like 6 pounds or something, 6-7 pounds, so it's not that much extra weight. And speaking of weight, a lot of you may be thinking, well, you're carrying around 200 pounds of batteries, isn't that going to affect your fuel economy and maybe even defeat the purpose of this, right? And yeah, that's a valid concern. So before I even went out and bought these batteries and built this system, I actually loaded the car to the maximum capacity. I loaded it with about 385 pounds of retaining wall block, just to see what difference it makes in the mileage. So what I did is I drove to work and back just myself, and recorded how many miles I used, and I was driving on cruise control, so I had a constant speed. So I didn't don't want to change too many variables. You want to drive at a constant speed. You don't want to have variables like one day you turn the AC on and one day you don't, or one day you have the headlights on and one day you don't. You want to just keep it at a constant operating conditions. And so I drove to work for a week and recorded how many miles the car used round trip, and then the next week I loaded up with 385 pounds of retaining wall block and did the same experiments, and found that, lo and behold, the extra weight was negligible. I think I lost maybe a mile, worst case, of range with all that extra weight. So I decided, it's a negligible effect to have that extra weight in the car. That's what the results showed me. So I went ahead and got these batteries. There's 200 pounds. Well, each one is 60 pounds, so that's about 180. Plus the inverter is about 5 or 6 pounds. So I have a little under 200 pounds. So it's basically like having a passenger in the front seat. And you wouldn't expect the car would, suffer tremendously with another passenger in the car. The manufacturer still specifies a certain range. It's about 80 miles with a full charge. So they're going to want the car to go at least 80 miles with 2 people in it. They're not going to want it to go 80 miles with 1 person in it. So it makes sense that, this extra weight isn't going to really kill you on the extra mileage. The worst gas mileage, well, not really gas mileage, but range. So what I've determined is that each battery gives me about 2 miles of range. So with these 3 batteries here, I have 6 miles of extended range. Now, people may say 6 miles, so what, big deal, right? But this car only has 80 miles of range originally. So you're adding 6 miles. That's not too bad, especially if you're in a situation where those extra 6 miles mean the difference between you being stranded on the road and making it home. That gives you a little bit of cushion. And I only have 3 batteries here. Had I put all 5 batteries, that would have given me 10 miles of range. So if your round trip to and from work, and let's say your work doesn't have any charging capability, they don't let you plug the car in, they don't have any chargers, so then you have this portable range extender, if you will. You get to work, you plug it in, give yourself 10 extra miles. So if you were cutting it close, now you have 10 extra miles of cushion. You don't have to have so much range anxiety. So, this is all off-the-shelf stuff. Nothing special here. The one thing I would want to point out is you do need a pure sine wave inverter. I originally tried this with a modified sine wave inverter, and the charger just didn't like it. It would fault, and it just wouldn't accept it. So I had to go with, spend a little more money and get this pure sine wave inverter, which provides basically a perfect sine wave. There's a little distortion, there's a distortion spec, plus or minus 3% or something like that. But I measured this on a scope, and it looked just as good as wall power, if not better. So this satisfied the charger, and as you can see, the charger is green. It's still charging. Car is still charging, and I'm not going to sit here for the entire amount that it's charging, but I've done this a few times, and it lasts anywhere from about 2 hours and 20 minutes to 2 hours and 40 minutes, maybe a little more. So say 2.5 hours of charging you get with these 3 batteries. So any additional battery you add to this bank, obviously you're going to get a longer amount of charging. And when you're charging at 8 amp setting, and the reason why I did 8 amp setting instead of 12 amp setting is so that I could get away with buying a smaller inverter. Had I gone to a 12 amp setting in the car, I would have needed a bigger inverter that would have cost more money, and I don't really need to charge it. Speed isn't really the factor here, because you're at work for at least 8 hours a day. You just need the thing to charge and give you extra range. So That's what I did here. I settled with the 8 amp setting, was able to get away with a smaller inverter, and you know, the car's charging, and it'll charge for a good 2.5 hours and give me 6-7 miles of extra range. So just wanted to demonstrate that. I'll do another video where I'll talk about the math of figuring out how to size this system, and you know, if you're interested in doing this yourself, it's not that complicated. It's pretty simple math, but I'll go over that and just explain how you put this together. Couple other things to mention are this inverter, when it gets to 10.5 volts. So you know, these batteries are constantly being drained down, and the voltage is continually dropping as this is charging. The voltage is dropping, and this thing is drawing more and more current as the voltage drops down. To compensate, to give it the, you know, the full amount of power, this inverter over here, this charger over here is 960 watt with your 8 amp setting. You know, 8 times 120 is a 960 watt. So this thing constantly needs 960 watt, and as the batteries are being depleted and voltage is dropping down, it's going to be drawing more and more current so that it can continually supply that 960 watt. Now again, this is a 1200 watt continuous 2400 watt surge inverter, so it's capable of supplying up to 1200 watt and up to 2400 with a surge, with an initial surge. You don't really get surge currents with this setup because we're not running a motor or anything like that. This is pretty linear power draw, if you will. So I'm not really worried about surge, but what you do want to make sure is that your continuous rating is higher than your load. And now I said that charger is 960 watt, but then this guy has a 10% inefficiency factor, so it takes 10% of the power itself. So if you add that in there, we're really drawing about 1100 watt. So I'll talk about the math in another video. For now, I just wanted to demonstrate this system. Alright, thanks.